46 now. Time to stare into space with Dylan Storey. Thanks very much to the Auckland Stardom Observatory. Dylan, come on in. Good morning.
Good morning, Wammo.
And for those watching the live video stream, it is apparent that the sun has not risen yet at Dylan Storey's house. It's still dark where he is. Pretty strange, I guess.
Still dark here in West Auckland. Is it like that everywhere in Auckland?
No, it's not. No, just at your house.
Weird.
That's
weird.
It is really strange. But it may have something to do with your fascination, of course, with staring at the stars.
It may or may not be related.
You may have stared a little bit longer than everyone else, perhaps. That's what's happened. Let's talk about the solar storm because that hit the news yesterday. It flew around social media. Oh my goodness, another solar storm on the way. We're all going to die. Someone turned on the lights at your house. That's nice. And we're all going to be without power. That hasn't happened.
No. There's even power at my house now. So yeah, I mean, the story's flying around. There's some great imagery out there of the solar flares now. And I mean, one thing that was bandied about quite a bit was people saying this is the biggest solar storm in 5 years.
Yeah, true.
Which is not true.
Oh.
There was a bigger one in August.
But these were proper scientists that were being consulted by the media yesterday. Were they wrong?
Us. Well, yes, I think they were, because this was a class X 5.4 solar flare. The bigger the number, the bigger flare, and there was an X 6.9 in August. And the thing is that 5 years ago we were around solar minimum. So there was. I actually remember looking at the sun, looking for solar flares at that time, and there was nothing happening.
Yeah.
So it's definitely not any kind of 5-year cycle. But we are, as we've talked about before, moving into solar maximum. They're part of the 11-year cycle.
Yep. Where
the sun becomes more active. So we are getting a lot more flares and sunspots. And the difference is with this particular 11-year cycle is that we've got a lot more high-tech observing equipment. So we've got the what we call the SDO, the Solar Dynamics Observatory.
Yeah.
And so that's what's giving all these really high-res images and videos of the solar flare, making them look really big and fearsome, as they are. And one interesting thing about this latest video that's come out is that it's captured and possibly coined a new term, the solar tsunami.
No, much like last week's weather bomb.
Yeah. Basically, it's that kind of rhetoric, isn't it?
Yeah.
But if you look at the video, and it's available online, the Solar Dynamics Observatory has got it, Universe Today has got it. It does show this kind of wave coming up from the solar flare going across the sun, which would be something like a tsunami. It's pretty impressive. So you can go online and find that. I'll put it on my Twitter feed, and you can put it on yours. And so we're just discovering a bit more about the nature of these solar flares and how one perhaps leads to another, causing waves of turbulence around and across the sun, which sort of lead to more magnetic instability, which perhaps feed onto more turbulence areas, causing more flares.
Yeah.
So we're learning more about the sun. And by the way, these tsunami waves move at more than 1 million miles per hour.
Wow.
So what's that? More than almost 2 million kilometres per hour. So quite fast. So we will be feeling the effects of that on Earth. When I say feeling, the wave of particles will reach Earth. They should be safely deflected by the magnetic field, as they have each 11-year cycle throughout the history of the planet.
Yeah.
We might see some minor radio interference caused by these waves of charged particles coming from the sun. Probably nothing major, though.
Nothing much to be worried about. Right, we're off to Mars now, where a dust devil has been spotted from the orbiter.
Yeah. So this is another very visual-based story, I guess, and listeners can look it up on the internet. One of the orbiting spacecraft has captured a dust devil, basically, like a twister on Mars from orbit, and it's given this amazing picture of this thing snaking up through the atmosphere and dissipating. So like we have dust devils on Earth, which I'll point out are very different to tornadoes. They kind of look similar, but they're almost the opposite effect. They're caused by heating from the sun, making air rise. So that's what's happened on Mars, is that there's very little atmosphere to block the heat from the sun, so it gets right in and it causes disturbance on the surface with Mars's atmosphere. Of course, Mars doesn't have very much atmosphere. It's only got 1% of that of Earth.
Yeah.
But still, that's enough to churn up winds, which will whip up a lot of dust from the surface, and dust can go high into the atmosphere. There's Martian dust storms are relatively common, but this is a Martian twister.
Pretty amazing. Pretty amazing, because it's cast a shadow over the land.
It's cast this big winding shadow across Mars's landscape, which is pretty awesome. So, as well as presenting a pretty picture, Mars twisters can tell us a bit about the composition of Mars's surface, because once that dust gets kicked up, then we start to be able to measure spectrums from the light diffused by it.
Okay.
And so it can detect the presence of different things on Mars's surface which may not have been picked up before. Mars is actually at its furthest away from the sun at the moment, so that solar heating effect is... Mars's orbit is a bit more elliptical than the Earth, so it moves a bit further away and a bit closer at times. So that heating effect is at its minimum at the moment, but again, like the solar stuff that we're seeing come through, the reason we're getting these images from Mars is just that we have much more high-tech equipment surveying it now. So this is taken from the HiRISE orbiter, which has actually gained more data than all other Mars orbiters put together. So this level is stepping up a bit. And as well as Mars being at its furthest away, it happens to be at opposition to Earth at the moment, so that brings us into the sky-watching aspect. Mars is very bright in the night sky at the moment. If you look up, last night I saw it was right by the full moon, so it was probably about a few fingers widths, or maybe a fist width away from the full moon. So tonight it will be similar. The moon will have moved on 12 degrees, but it will still be back. If you look at the full moon tonight, kind of look back to the west slightly, probably about the distance of your outstretched hand at arm's length away from the moon, you'll see the bright red Mars. So it's very easy to see. Mars is at its opposition, meaning it's closest to Earth. So in our orbit, we're right by it. We're sort of overtaking it.
All right. Well, I'll have a look out for it this evening, and of course you can do the same at the Auckland Stardome Observatory. Dylan Storey, people can continue the conversation with you on Twitter, twitter.com/Dylan Storey. Thanks very much.
Thanks, Wammo.
Time now here on Kiwi is 7:54.